Okay, good morning everybody. Hey, it is April 30th, so it's Landon's birthday. So if you guys see or text Landon, say happy birthday Landon. Landon's B-Day, he's 17 today. Yay Landon. Okay, so here's what we got to do today. So first of all, let's take a look at the homework. And I had a text from somebody saying, please can you show the last three problems or how to do them? So I'd be happy to. So first, let's look at this, okay? So these are pretty simple. If that's 13, 13, that's 26. 8 and 8, 16. 26, 26, 52. The bisector is point M. The bisector is ray MN. The bisector is line L, okay? 4, set x equals 1. So plug it back in, we get 12. Set them equal, solve for x is 3. Plug it back in, we get 36 for the entire length. We solve for x is 4, plug it back in, we get 8 and 8 or 16. Okay, now, midpoint, if you use the midpoint formula, you get negative 2, 4. 8, the midpoint is 4, 2. 9, the midpoint is 6, negative 9. Now, how do you do the next step? Well, there's two ways, okay? Two ways. One is to graph it. I'm going to show you what I mean by graphing, okay? So, let me get my graph paper out. The other is to use formula. I'm going to show both ways on 10. So, first of all, 10. Let's take a look at number 10. So this is one way to do it. This is by graphing, which is a little bit tedious. This is not the way I would always do 10, but I'll show you both ways, okay? 7, 2. 1, 2, 3, 4, 5, 6, 7. 1, 2. There's J. M is at 1, negative 2. There's M. Now, if this is half of the segment, that's the way to look at it, okay? This is half the segment, okay? Then the other half, the other point's got to be down here. Does that make sense? If this half, that's the midpoint, M, then somewhere down here is the other point. So I can count. If I counted down, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. This is probably the easiest way to see it, and that puts me way down there, and we'll call that point, or they want us to call it point JK. So they want to call it point K, which in this case is the coordinate 1, 2, 3, 4, 5, negative 5, 1, 2, 3, 4, 5, 6, negative 5, negative 6, okay? Okay, another way to do this, okay, is to use the formula, okay? And I'm going to show you the formula when I do number 7 or number 12, because 12 is not that easy. If you want to go ahead, because you got the decimal, the fractions, so how do you do it? So let me show another way to do this one, okay, 12. Here's our formula. Formula is x2 plus x1 over 2 equals my midpoint of my x value. And I've got my y2 plus my y1 over 2 equals the y value of my midpoint. Okay, so I'm going to do this. Negative 9 halves is the x value. So I'm going to put that right here. Negative 9 halves, because that's the midpoint. And 7 I'll put here for the y. So the negative 9 halves I'll put here for the x value. And 7 I'll put here for the y value. Okay, now I've got an x value of 2. So I'm going to put 2 in right here for an x value. Remember, that's an x and a y. So I'll put that right in there for 2. And for the 16, I'll put that right in there for 16. Okay, now I've got a little mini equation. So let's see what I have. Okay, so this is the other way to do it. So I got an x2 plus 2 divided by 2 equals negative 9 halves. Let's change that to negative 4.5. Be easier to read. Okay, and then the other is here. Get my y2 plus 16 over 2 equals 7. Okay, so this takes a little bit of algebra, a little bit of math, but we can do that. Okay, so I'm going to multiply by 2 on both sides to cancel out this 2. Okay, and so then I wind up with a x2 plus 2 equals, that's a negative 9, minus 2 minus 2, x2 makes a negative 11. Okay, I'll do the same thing on this side. I want to undo the divide by 2, so I'll times by 2, boom, boom, times by 2 on both sides. So I got a y2 plus 16 equals 14. I'll go minus 16, minus 16, and I get a negative 2. Now remember, it's point, so let's write it as a midpoint. So if we write it as midpoint and we put it as negative 11, negative 2. Okay, so two ways to do it: graphing it, or you can just do it by algebra. Okay, using the midpoint formula. Okay, so that's the homework. Okay, what about today? Well, today we've got some work to do, so we can do that. So today we're going to continue more into geometry. So hopefully you know these names, but if you don't, we're going to put them down real quickly. So we should know the name of a three-sided figure. So these are polygons. Poly means many. Poly means many, and gons means sides. So many-sided figures. Okay, so what I want to do here, and I think you know these. If you don't, I'd be surprised. You'll learn these at least in middle school, maybe even in Sesame Street, some of them, right? Love Sesame Street. What you can learn from Sesame Street. So some of these are a little bit weird, like, you know, maybe an 11-sided figure. You might not know that one. You probably know a 12-sided figure. Okay. And there we go. So, three-sided figure we know is a triangle. Or a trigon, because you're going to see a lot of these have gon names and trigon. Four-sided figure is not a square. Not specifically, because there's lots of different size four-sided figures. Let me draw you a picture. Okay, that is not a square, so we call it a quadrilateral. Five-sided figure, hopefully everybody knows about the pentagon. Sure enough, the pentagon in Washington, D.C. is shaped like a pentagon. It's a regular pentagon. Six-sided figure is a hexagon. Seven-sided figure is a septagon. Or another name is a heptagon. Just another name for it. Eight-sided figure, what everybody should know by, like an octopus, octagon. Nine-sided figure is a nonagon. 10-sided figure is a decagon. Hopefully you guys know these. 11-sided figure is an undagon. Weird, huh? Undagon. And a 12-sided figure is a dodecagon. Now, beyond that, we stop giving them names because it gets ridiculous. So 13agon, it's just a 13agon. 14agon. 15agon. And so forth and so on, because we just stop making names, okay? So those are the names of our polygons. I got this cool template around here somewhere that I could draw these. So I've got all, here we go. Here's my cool template. So you can see all of these awesome figures. You can see these different figures, all these different figures. See pentagon, hexagon, looks like an octagon. Anyhow, let's move on. So those are our many-sided figures, our polygons. Polygons, many-sided figures. So let's check it out. So objective today, we're going to talk about polygons. We're going to talk about their perimeter and the area, that's the hard part of the lesson today, but we'll get there. So, convex or concave is super easy, okay? It got caved in, it got dented, somebody kicked it. Think about somebody just taking their foot and they just kicked it right in, pow. So you think about your foot. I'm not very good at drawing, you guys know that. Someone took their foot and they kicked it in, okay? So it got caved in. This is a 1, 2, 3, 4, 5-sided figure, so it's a concave pentagon. It's a concave pentagon. Got kicked in. It's that easy. This is, everything's popped out, so this is a convex hexagon. Concave, let's see how many, 1, 2, 3, 4, 5, 6, 7, 8. Concave octagon. Oh, let's see what's this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This would be a convex dodecagon, okay? Alright, now, example 5. I'm not going to do all of these because these are also like what's in your homework, so I don't want to do them all. I'm trying to do some of them, okay? So let's graph it. Find the perimeter and area of the polygon. Okay, let's see. I don't think this one's going to be that hard. Put my XY axis down, and I'll graph it, okay? Okay, some of these are very similar to what you're going to see in the homework, so that's why I don't want to put too much work in this, okay? So, let's graph it. I'm going to have a point at 2, 4, x, 0, negative 2, there's y, and 2, negative 2, there's z. So, take a minute, and I'm going to draw in my triangle. We'll get perimeter, and we'll get area. So, what makes this problem a little harder is the fact that if you want perimeter, this length xy is going to be hard. Okay. So first of all, perimeter. Let's add. Perimeter is just this add all the way around. This side plus this side plus this side. So that side's 2. This side's 1, 2, 3, 4, 5, 6. But the diagonal or the hypotenuse we don't know. So we're going to use Pythagorean's theorem. Okay. So to find xy, we're going to go and use our Pythagorean's theorem. We're going to go 2 squared plus 6 squared equals c squared, which is xy. 2 squared is 4. 6 squared is not 12, but 36 equals c squared. You add that together and you get 40 equals c squared. Square root it. And let's see what we get. Well, in my calculator. And clear, I'm going to go square root of 40. And I get it to be about 6.3. So this is about 6.3, okay? This length here is 6.3. So perimeter. All right, let's do perimeter then. So we're going to go 2 plus 6 plus, well, the 6.3. 6.3 blah, 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 blah. And if we add them all together, we can answer about 14.3 units. Okay, we don't know what the units are. It could be, inches, centimeters, whatever. Okay, so there's the perimeter. Got that answer. Okay, now let's figure out what the individual area is. Well, so we have to know a formula. So we know the area of a triangle. It's going to be area is equal to 1/2 the base times its height. Hopefully you know that. If not, there it is. So to find the area of this triangle, we're going to go area is equal to 1/2, because that's half of a square, 1/2. 2 times 6, because that's the height. Half of 12 is 6, and that's going to be in terms of units squared. Okay. And again, I'm only going to do part of this because this is like right out of your journal. So I want to make sure that I only do part of it. So I leave the rest for you. Okay, turn the page. Now, here is the hard one. We can do this. All right. So, find the perimeter of a triangle ABD. Okay. All right, we're going to do the same thing. So, perimeter. Let's just count it up. All right. And this is right out of your journal. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. But I don't know AD. We'll call that C. So what I'm going to do is use my Pythagorean's theorem. So I'm going to go through and I need to find AD. It's going to take some work, but I can do this. And I'm going to go a squared plus b squared, 5 squared plus 6 squared equals c squared. So I'm going to go 5 squared plus 6 squared equals c squared. 5 squared is 25 plus 6 squared is 36 equals c squared. 25 plus, let's see, it's 61, I believe, equals c squared. And then again, we'll square root it to get that answer. Okay. Okay. We're going to just take the square root of that answer. Square root of 61. I get an answer about 7.8. So the perimeter of ABD is going to be perimeter all the way around ABD triangle is going to be my 5 plus my 6 plus my 7.8. Okay. 5 plus 6 plus 7.8, and I can answer about 18.8 units. Okay, so then I'm going to leave some of this, the rest of this to you because it's in your homework. BDC, BDC. You're going to have to find these by Pythagoras theorem. And the area of triangle ABD is easy. 6 times 5. Base times height. Area is always going to be 1/2 base times height. I will help you with one thing, and that is if you want the triangle, the area of this triangle right here. Okay, highlight it. So if I want the area of triangle BCD, right there, BCD, you have to know that the height, here's the height, draw it in. There's the height is 1, 2, 3, 4. And you can see the base is 1, 2, 3, 4, 5, 6. Okay? Alright, so homework. And I specifically did this on purpose so that you guys can see that homework is very similar to what you're going to see in the journal. In fact, it's the exact same problems. So if I go to section 8.4, there's a problem right there. Okay, exact same problem. So we've done some of it. I've done some of this as well. I did that on purpose so that to help you out. So homework today is page 234. And 235, both pages. I want you to do 1 through 14 all. Okay, guys, have a great day, and I'll talk to you tomorrow.